Welcome. Today we're digging into a really critical report for any enterprise architect out there. It's a 2026 analysis on the economics of agentic AI. You see, as an industry, we've kind of moved past the era of just training models. We're now in the hard reality of actually using them, and wow, the financial implications are turning out to be pretty staggering.
So here's our game plan. First, we're going to uncover a nasty hidden AI tax that's just wrecking budgets. Then, we'll look at the industry's default solution, which is, frankly, deeply flawed. After that, we'll get into the good stuff, the architectural revolution that not only fixes the problem, but can deliver a massive financial payoff.
All right, let's kick things off with the hidden economic reality of this whole AI boom. There's a sustainability crisis quietly brewing behind the scenes. We're talking about invisible costs that are compounding and threatening the entire viability of large-scale agent deployments.
And look, this isn't just an isolated issue affecting a few companies. It's a shared pain point across the board. A staggering 96% of senior decision makers are reporting that their AI costs have spiraled way beyond what they originally planned for. Now, this isn't just a simple budget miscalculation. It's a systemic problem, and it has a single identifiable root cause.
So what's the deal? The primary culprit is a hidden cost this report calls the recursion tax. Think about it for a second. Unlike a simple chatbot that just gives you one answer, an agent actually thinks, it plans, it reflects, it self-corrects, all in a loop. And every single cycle of that internal thinking generates more data, more tokens that you, my friend, have to pay for. It creates this massive spiraling cost multiplier.
And the scale of this problem? It's genuinely alarming. The moment an agent enters that deliberative thinking loop, the cost for the exact same conceptual task can skyrocket by up to 25 times. That's the recursion tax in action, and for any enterprise, that is just economically ruinous.
Okay, so this crippling tax leads us right to the industry's go-to strategy for handling complex reasoning. Just throw more power at the problem. Deploy these absolutely massive generalist models. But as you're got to see, this is a lot like trying to put out a fire with gasoline.
And don't get me wrong, there's no denying the raw power of these frontier models. I mean, they're computational behemoths. They have staggering parameter counts and context windows that can hold entire libraries of text. They are the ultimate generalists, really, designed to solve problems through sheer scale.
But all that brute force power comes with a severe price tag. The serverless inference costs you're looking at here are already pretty high. Now just imagine multiplying these numbers by 25 because of that recursion tax. All of a sudden, the economics become completely and totally unsustainable for any enterprise trying to operate at scale.
So, this leads us to a conclusion you just can't avoid. The bigger is better approach is an economic trap. It's a marvel of computation, for sure, but it's financially perilous. And this reality forces us to ask a really fundamental architectural question, and believe me, the answer requires a radical shift in how we think about this. And this brings us to the revolutionary new approach. Instead of focusing on brute force scale, the solution lies in algorithmic elegance and pure computational efficiency. The breakthrough isn't a bigger brain, it's a much smarter way of thinking.
The paradigm shift here is just profound. We're not talking about a small optimization. We are moving from models with hundreds of billions of parameters to a whole new class of hyper-efficient models with just 7 million. This isn't just an improvement, it's a fundamental split in architectural philosophy.
And here's the kicker. The results completely defy conventional wisdom. On the ARC-AG benchmark, which is a test of pure abstract reasoning, the 7 million parameter Tiny Recursive Model, or TRM, it actually outperforms its massive competitors. This is definitive proof. Complex reasoning is an algorithmic challenge, not a scale problem.
So how does it do it? Well, its secret lies in this incredibly lean architecture. Instead of relying on brute force memorization, the TRM simulates how humans solve problems. It has dedicated components to manage its own iterative loops and even a metacognitive layer to critique its own logic. This allows it to converge on the right answer super efficiently. The financial implication of this is almost hard to wrap your head around. By replacing raw scale with algorithmic elegance, the TRM is roughly 1,500 times more affordable for the specialized logic and routing tasks that are really at the core of most agentic workflows. Yeah, just let that sink in. This isn't an improvement, it's a complete disruption of inference economics.
But pure logic? that's only half the battle. Enterprise agents also have to handle massive amounts of data, documentation, conversation histories, tool outputs, without those costs just spiraling out of control. And this introduces our next major challenge.
We're talking about the problem of context explosion. You see, as a long-running agent interacts with users and tools, its memory of that history just gets more and more bloated. Eventually, it overwhelms the context window, and that causes the agent to slow down, make mistakes, and just burn through cache. So the solution is this really intelligent compression scheme called context folding, and it's implemented through a system known as the U-fold framework. The goal isn't to forget the past, but to smartly summarize it. It uses a two-part process to preserve the essence of the history, the user's intent, and key data, while getting rid of all that costly token bloat.
The impact on the agent's capability is profound. By folding these inactive branches of reasoning into compressed little representations, this framework delivers a staggering 24-fold increase in the effective context an agent can manage. So this means agents can now work with massive code bases or entire sets of documentation without their performance falling off a cliff.
And there's a huge performance benefit too. By shrinking the prompt size that has to be processed in each one of those thinking loops, context folding achieves a 45% reduction in latency. So the agent isn't just cheaper, it's faster and way more responsive.
Okay, so we've got our two key technical solutions, hyper-efficient models and smart memory management. Now let's connect the dots and see how this superior architecture translates directly into undeniable business impact and, hard ROI. This is where that engineering excellence really becomes a profit center.
And this isn't just theory. The report's evidence grid quantifies the results across different industries. Mature enterprise deployments that adopt these efficient architectures are not seeing marginal gains. They are routinely achieving 5x to 10x ROI multipliers for every single dollar invested in agentic automation.
And this brings us to a really critical insight from the report. The most lucrative application of this tech isn't about replacing people. It's about augmenting your best people, compressing the time it takes to do a task by just eliminating all that low-value, high-friction work that just drags down productivity.
And to see what this actually looks like in the real world, just take a look at healthcare. Adopting this efficient architecture saves each physician 66 minutes per day on clinical documentation alone. That is over an hour of highly valuable expert time reallocated from administrative work back to patient care every single day. So all of this really boils down to one final provocative question your organization has to face. By 2026, mastering the economics of machine thought, it's not going to be optional anymore. It stops being a technical challenge and becomes the single defining factor for market leadership. The battle for the future will be won by those who can optimize the cost of thinking. If you found this analysis helpful, please like and subscribe to the Automation Architect channel.